Hey folks, Miss A here. I had a question on number 25. So we were asked to find the inverse of this function. And whenever you're asked to find an inverse, right, you do want to check that the function is one-to-one. So I'm just going to do like a quick sketch. So this is going to be a rational function. So if I make my xy axes, I've got a domain issue at -7. So let me scooch out to there. 1, 2, 3, 4, 5, 6, 7. So I'm going to have a VA here. And I'm also going to have a horizontal asymptote at y equals 1. And then it pretty much looks like your toolkit function 1 over x. It's going to look something like this-ish. And that is going to pass the horizontal line test. So we do know that function is 1-to-1, which means that the inverse exists. And the first step in finding the equation of an inverse function is to stop using the fancy f of x notation and let's replace that with y. So that's what you see me doing here. And then the next step is always to interchange x and y. So what that means is you can see there's an x here and here, and I'm going to replace that with y's at the next step. And then conversely, you can see there's a y here, and I'm going to replace it with x. Once you get to that phase, once you've replaced or interchanged x and y, the next thing is to solve for your new y. And it can be a little funky because we have y in a numerator and denominator. And so I'm going to delete all of my little work right now, okay? And then for this kind of problem, what I'm going to do is I'm going to go opt to cross multiply. And we typically do that when we have rational functions and we need to find the inverse. So x can be written as x over 1, right? So I can cross multiply, which is why on one side of this equation you see x times y plus 7. And on the other side you see y minus 2, because 1 times anything is itself. So 1 times y minus 2 is y minus 2. And now I'm going to go ahead and distribute that x, right? And you see that playing out here. All right, and then keep in mind your goal, right? You want to solve for y. That's always the goal after you interchange x and y. So if y is the variable I want to get isolated, essentially what I want to do, let me go back to my highlighter, I want to get all the terms with y on one side of the equation, and then all of the terms without y on the other side of the equation. And it doesn't matter which order you go in, just as long as all the terms with y are on one side and all the terms without it are on the other. So what I mean by that is I'm going to move this one over here, right? And I'm going to move these two, well, actually 7x is already on the list. I'm going to move the 2 over here. So that's where I wind up with this, okay? And then if you look at what's on the right side of this equation, I want you to take note that there's a GCF. So I'm gonna rewrite this. I can write this as 7x plus 2, and then if I factor out that GCF of y, I'm gonna get left with 1 minus x, right? So in those two terms, there's a GCF of y, I factor it out, and then that allows me to solve for y, because now what I want to do is to divide both sides by 1 minus x, and I've got now all of a sudden y is all by itself. Right? And so once I get here, I've found my inverse equation. I go back to using fancy function notation and I call it a day. Okay? Thanks so much, everyone.